We usually compare quantities and values by calculating their difference. For example, if we have to compare the weight of two individuals who are 45 kg and 35 kg, we will say that first one is heavier than the second one by 45 minus 35, which is 10 kg. If we wish to compare the price of two umbrellas that cost 200 rupees and 150 rupees, we can subtract 150 from 200 and conclude that the blue umbrella is costlier than the red one by 50 rupees. Comparison by difference does not give a clear picture when we compare quantities or values that are wide apart. For example, if we compare a pencil that is 6 inches long with a badminton racket that is 24 inches long, the difference between the two lengths is 18 inches. However, the difference does not clearly bring out the extent of variation in the lengths between the two objects. Is there any other way to express this variation? If we place pencils beside the racket, we will see that 4 pencils are required to cover the length of the racket. In other words, the badminton racket is 4 times longer than the pencil. Comparing a quantity as how many times the other quantity is called a ratio. Now, let's get back to finding the ratio using the lengths of two objects. 24 divided by 6 is same as 4 divided by 1. 4 divided by 1 can also be expressed as 4:1. So this time we mathematically establish that the length of badminton racket is 4 times the length of pencil. Colon is the symbol used to denote ratio. Now that we know what exactly is ratio, let's figure out the ratio of the cost of two different merchandise. Rahul bought a pair of sneakers for 500 rupees and a pair of socks for 100 rupees. Now what we have to figure out here is the cost of sneakers is how many times the cost of socks. To calculate the ratio, first divide 500 by 100. It is the same as 5 divided by 1. We can express it as a ratio, that is 5:1. So we can say that the pair of sneakers is 5 times costlier than the pair of socks. One thing to be remembered here is that two quantities can be compared only if they are measured in the same unit. Let's see how. Pooja has 200 grams of sugar in a bowl and 1 kilogram sugar in the jar. We know that 200 is greater than 1, but can we say that the quantity of sugar in the bowl is more than the quantity of sugar in the jar? No. The reason being, two quantities here are represented in two different units, so they cannot be compared. To make them comparable, we will have to express both of them in the same units. If we express 1 kilogram as 1000 grams, both the quantities will have the same unit and hence will be comparable. Now we can find the ratio. 200 to 1000 is the same as 1 to 5 or 1:5. So sugar in the jar is 5 times more than sugar in the bowl. Now let's talk about equivalent ratios. If two sets of ratios are given as 2:3 and 2:3, we can clearly see that both are same. So obviously these are equivalent ratios. But if the ratios are like 8:4 and 12:6, the numbers seem very different. So at the first look, we cannot say whether the ratios are equivalent or not. To check if the ratios are equivalent or not, we need to reduce these ratios to their lowest terms and see what we get. In case of 8 is to 4, if we divide both the numbers by 4, what we get is 2 is to 1. On the other hand, if we divide both the numbers 12 and 6 by 6, what we get is 2 is to 1. So we see that 8 is to 4 and 12 is to 6 are equivalent when seen in their lowest terms. Ratios that are equal when reduced to their lowest terms are known as equivalent ratios. Let's now understand the equivalent ratios with the help of an example. Harsh calculated the ratio of boys and girls in his class. The class had 30 boys and 10 girls. Dividing both the numbers by 10, the ratio worked out to be 3 is to 1. He then calculated the ratio of books and notebooks in his bag. There were 21 notebooks and 7 books in the bag. Dividing both numbers by 7, the ratio worked out to be 3 is to 1. He wondered, can the two ratios be same when the numbers are so different? Yes, they can be. The first ratio tells us that the boys are 3 times the girls, and the second one tells us that the notebooks are 3 times the books. Ratios can be very effectively used to divide quantities and values. Let's see how. Two friends, Hari and Prasad, made a business investment. Hari invested 6,000 rupees and Prasad invested 4,000 rupees. After some period of time, they made a profit of 1 lakh rupees. They decide to split the profit in the same ratio as that of investment. How would they know who gets how much? First, they need to find the ratio of their investment. The ratio of investment was 6,000 divided by 4,000, which after reducing to the lowest terms turns out to be 3 is to 2. So they will share the profit in the ratio 3 is to 2, which means that in every 5 rupees of profit, 3 will go to Hari and 2 will go to Prasad. So Hari's share in the profit will be 3 by 5 multiplied by 1 lakh, which is 60,000. And the share of Prasad will be 2 by 5 into 1 lakh, which is 40,000. If you have two ratios that are equal or equivalent, then these ratios are said to be in proportion. Let us understand this with the help of an example. Ria bought 16 headbands for rupees 128 and Julie bought 12 of the same headbands for rupees 96. Is the purchase of any one of them more expensive than the other? How do we find out? First, we will have to work out the ratios of the two quantities. The ratio of quantities is 16 is to 12, which in its lowest terms would be 4 is to 3. Now, we need to work out the ratio of the prices. The ratio of the prices would be 128 is to 96, which in its lowest term is 4 is to 3. As we see that the ratio of the quantities is same as the ratio of the prices, it is proved that both paid the same price for the headbands they purchased. When two sets of ratios are equal, they are said to be in proportion. Ratios in proportion are represented in this manner. This is the symbol used to denote proportion, which is placed between the two ratios. Each number used in the proportion is called a term. First and the last terms are called extreme terms. Second and third terms are called the middle terms. Now it's time to discuss unitary method. The method in which first we find the value of one unit and then the value of required number of units is known as unitary method. Let us understand this with the help of an example. The annual membership fee of the sports club for Arun is 18,000 rupees. He wants to know the cost of 3 months membership. For that, he will have to calculate the cost of 1 month's membership first. Let's do that for him. Membership cost for 12 months is 18,000. Membership cost of 1 month would be 18,000 divided by 12, which is 1500. Now we can easily calculate the membership cost for 3 months by multiplying 1500 with 3, which would be 4500. Here we calculated the cost of membership for 1 month and then multiplied that 1 month cost by 3, as we wanted to know the cost of 3 months membership. So here we used the unitary method.